All right, well, we're moving our way through chapter 2. We're now at chapter section 2-2, polynomial functions. And here we're first going to look at graphing transformations of monomial functions. And this is coming from example 1, which is on page 98 of your textbook. And we're going to look at both 1A and 1B in this little video lesson. So here we're asked to graph the function f of x equals 4 minus x cubed. And I'm going to kind of give an explanation of what I think we should see on the graph, and then we'll post up where I'd actually graph this function on the calculator and confirm that. Now, I could enter this just like it is, 4 minus x cubed. In fact, I did just that when I entered it in the calculator. But I could also rearrange this function to appear this way. Let's see, we'll go white here. I could have negative x cubed plus 4. And of course, that's the same thing. I just rearranged the function equation. Now, I've got a cubic function, so I have a general idea of what it's going to look like, and I've got a negative 1 coefficient. That negative x cubed is a negative 1 coefficient, and then I've got a plus 4. And the 4 is not inside of parentheses, it's outside of the parentheses. So ordinarily, if this was a positive cubic function, I would expect it to look something similar to that right there. However, since this is a negative cubic function, I'm expecting this actually to flip around, and I think it'll look something like this right here. And then with this positive 4 sitting out here, outside of a parentheses, not inside of a parentheses, I'm expecting it to translate vertically up 4. And so that rather than my intercepts being at the origin 0, 0, I'm expecting my intercepts to be x-intercept at 0 and the y-intercept at positive 4. So let's see what the results are after I have graphed this function. And you can see that it's got all the shape of a cubic function, which it should have. It has flipped it upside down because of that negative coefficient, and I do in fact have the intercept here is when x is 0, y is 4, and so it's translated up 4 vertically. So there you go. So I can anticipate, if I look at the function equation, I can anticipate what I'm going to see, and then after I graph it, it should confirm that. So we're going to take a look at another one here, and before we move and continue on through this chapter section. Okay, so in this example, and this is coming from example 1, page 98 in your textbook, this is guided practice 1B. We're asked to graph the function g of x equals, in parentheses, x plus 4, and everything in the parentheses is raised to the 4th power. So again, I'm looking at the x. I got a leading coefficient, and so I'm expecting the end behavior to be both going hands up, what I'd call hands up, because it's an even function with a positive coefficient. And since this plus 7 is inside the parentheses, I'm expecting a transformation to the left along the x-axis. So ordinarily on an even function, we're going to see something that would look similar to this. I think actually we probably won't be able to see it on the calculator, but with it being a function to the 4th power, it actually will be something like that, look almost more like a W. Although, again, unless you got your window set right, you'll probably see it more looking like this one right here. And then I'm going to expect to see that this graph of this function is going to translate to the left 7. And so I'm expecting now the y-intercept to be at -7. The x-intercept to be at -7. And I'm also, and the, I don't think it'll have a y-intercept at all, to tell you the truth. But that being the case, let's take a look and see what we got. And so here's the graph. It does have that basic parabola shape. And well, let's see, we have translated it. There's 1, 2, 3, 4, 5, 6, 7 places to the left, going to the left down the x-axis, where the y-intercept is at -7. And there we go. We see a graph of the function g of x equals, in parentheses, x plus 7 raised to the 4th power. So again, you can look at the equation, get a general idea of what your graph's going to look like, and then when you graph it, if it confirms that, well, then you're probably correct. Okay. Does it get much more exciting than this?